This presentation aims to show how switching from traditional light globes to energy-efficient globes can lower my environmental footprint and the mathematical process used to work out the energy savings from this. Understanding the problem. Why is environmental sustainability important? Our actions on the environment have consequences. Communities need to understand the responsibilities of their actions on the environment. Some of these actions include taking too many resources from the earth, polluting the air, which in turn affects the atmosphere, over-farming land, and the production of endless waste. These consequences could cause irreversible issues for society and the planet as a whole. Some problems that could arise from these actions include rising sea levels, running out of oil to fuel our machinery, and pollution of water sources that will result in clean water becoming non-existent. Creating a sustainable society and ecosystem. By making better choices about how we use energy and what we consume, everyone can lower their environmental footprint to help maintain and better our planet. How will changing from traditional light globes to energy-efficient globes lower my environmental footprint? Energy-efficient light globes use only 20% of energy compared to traditional incandescent light globes. They also last between 4 and 10 times longer than traditional globes and can reduce the amount of lighting energy in an average household by up to 50%. While looking at the mathematical problem of how much energy I could save in my household, I came up with a few questions of my own. These include, how much energy can really be saved? What would the cost of replacing all of the globes in the household be? How many globes are in the house? How much cheaper would the electricity bill be? Is the cost worth the amount of energy saved? What does my electricity company charge me per kilowatt? What is the difference in watts between traditional incandescent globes and fluorescent energy-efficient globes? Making a plan. These are the steps I came up with to work through the problem. The first step is, what am I working with? Firstly, I need to research the energy output for both a traditional and energy-efficient light globe and decide which energy-efficient globe I wish to use. I also need to research the cost per kilowatt of energy from my electricity bill and the cost of purchasing energy-efficient globes. I then need to count how many globes are in my house. What maths do I need? I'll be using a few different mathematical processes for this problem. They include multiplication, working with decimals, converting watts into kilowatts and cents into dollars, as well as subtraction. Solution. Once I have a solution, I need to analyze the data to see if it is financially viable to switch to fluorescent globes. Carrying out the plan. The numbers. From my research, I came up with the numbers I will be working with. There are 18 light globes in my house. An incandescent globe runs at 25 watts and a fluorescent globe runs at 6 watts. A fluorescent light globe costs $8. My electricity company charges 23.95 cents per kilowatt, and finally, a 25-watt incandescent globe uses 0.025 kilowatts per hour, and a fluorescent globe uses 0.006 kilowatts per hour. In the next few slides, I will break the problem down. First, I'll see how many hours we will be working on. Let's say the lights are on for 8 hours per day, every day of the year. So 8 hours times 365 days equals 2,920 hours. Now I will determine how many kilowatts per year each globe will use. An incandescent globe uses 0.025 kilowatts per hour, so I will multiply this by 2,920 hours, which equals 73 kilowatts. A fluorescent globe uses 0.006 kilowatts per hour, and this multiplied by 2,920 hours equals 17.52 kilowatts. To determine how much energy the whole house will save per year, I need to multiply the kilowatts per individual globe by the amount of globes in my house. So an incandescent globe uses 73 kilowatts per year, multiplied by 18 globes equals 1,314 kilowatts of energy output per year for the whole house. A fluorescent globe uses 17.52 kilowatts a year, multiplied by 18 globes equals an energy output of 315.36 kilowatts per year for the whole house. To determine the answer to the ultimate problem, I need to minus the amount of kilowatts per year a fluorescent globe uses from the amount of energy per year the incandescent uses. So 1,314 kilowatts minus 315.36 kilowatts equals a saving of 998.64 kilowatts per year. Putting it all together. Now that I have all of the relevant equations to solve the problem, I can put it all together into one large equation. To determine the household energy saving of using fluorescent light globes instead of incandescent light globes over a year at 8 hours per day of 18 globes, we first multiply 8 hours by 365 days to determine the amount of hours an incandescent globe is in use. We then multiply this by 0.025 to determine the kilowatts per year an incandescent globe uses, and multiply this by 18 globes. We then do the same for the fluorescent globes at 0.006 kilowatts and minus this from the first part of the equation to get the answer of a savings of 998.64 kilowatts per year. Next, I wanted to work out what the savings cost in dollars would be on my electricity bill per year. To do this, I multiplied the savings in kilowatts per year by the cost per kilowatt of energy used for my electricity bill and divided this by 100 to convert it into a dollar value. The result was a saving of $239.17. Although I have concluded that it will definitely lower my environmental footprint to switch to fluorescent globes, I was wondering, is the cost of replacing all 18 globes going to be a downfall? To work out the cost of changing every globe in my house, I multiplied the cost per globe at $8 by the amount of globes, which is 18, and came up with the result of the initial outlay to replace all of the globes would be $144. To conclude whether it is worth changing the globes from a financial aspect, I subtracted the initial outlay cost of $144 from the savings per year on my electricity bill, which came to $239.17. This result still gives me a saving of $95.17 in the first year. In terms of lowering my environmental footprint, I would be using 998.64 less kilowatts per year by switching to fluorescent globes. Not to mention, I would be lowering the amount of waste I produce, as the globes can last 4 to 10 times longer than incandescent globes, so they wouldn't need replacing as regularly. In the first year, I would save $95.17 after the initial outlay cost of changing all of the household globes. In subsequent years, I would save $239.17 per year on energy use. However, I would save more due to the longevity of the globes and not needing to replace them as regularly.